We're now moving to from the plenary now to our keynote speaker, and once again we're very happy to have someone, in this case from the United Kingdom. So Phil Williamson has a dual role, both with the National Environment Research Council in the UK, but then also with the University of East Anglia in Norwich. And it's a great pleasure to welcome Phil to tell us a little bit about multifaceted carbon dioxide removal processes. Phil.
Thank you very much, Phil, for that introduction. And as you said, I work for NERC, Natural Environment Research Council. I'm based at the University of East Anglia, and NERC, with other UK research councils and with co-support from the government, are currently supporting a greenhouse gas removal research programme to the value of about £11 million. It started last year, and so there's various logos and credits along the bottom to acknowledge that support. So although that programme has only just started, so I'm not really giving results from that, but I'll be touching on some of the issues raised. Now, I thank Phil very much, for Philip Boyd, for inviting me and putting me here, and also for providing me with the title for the talk, Multifaceted CO2 Removal Processes. But it was some time ago when I signed up and agreed to that, and then I looked at it and I thought, well, I'm not really... So it's not quite me, that title. So I've changed the title. In deference and in respect to our organisers, it's sufficiently broad and general, or hopefully to cover what I will be talking about. But I really actually didn't know what it meant. And as you'll hear, I am quite keen on knowing what things mean. So if that works, then I've changed the title somewhat. Still fits in the box. 10 premises for greenhouse gas removal, and that was actually stimulated by a workshop conference that I went to a month ago in Reading, and within our UK programme, we are transdisciplinary. I think that's the same as being integrationist, but it means putting a whole lot of things together, being transdisciplinary, the technological, the environmental, social science, also the ethical and philosophical. And it was at a philosophical meeting, or a Department of Philosophy, that I was at in Reading a month ago, and they were debating and discussing the philosophy of climate geoengineering. And instead of having hypotheses, instead of having evidence, instead of having data and information and lots of graphs, and philosophers being philosophers, they talk about things, and they don't have assumptions, they don't have hypotheses, they have premises. And I rather like the idea of having premises, because on premises for green, you can put things in premises, but it's a bit like an assumption, saying, well let's start from here, say something bleeding obvious, find out whether it's true or not, and then say, well, where does that lead us to? Are there any steps along the way? So some of the things that I'll be covering have already been said, and much more fluently and much more sort of technological, and some of the things might be said in future sessions, but it's just a different way of structuring, because it's great to have a keynote, so I've got 50 minutes, and I can carry on talking all that time without, well, someone might be waving things, so I might finish early. However, so we've got this transdisciplinary programme, we've got premises, and if you're not quite sure what a premise is, if the premise is true, then the conclusion must be true. So if you agree with me. However, I'll still have stepped back a little bit, that NERC has not cleared what I'm going to say because I never told them, and UEA don't mind what I say, so if anything's quoted, it's from the University of East Anglia, but not Natural Environment Research Council, because it's funded by government, so got to be a little bit careful there. Okay, so let's get on with it and have our first five, and some of them statements of the bleeding obvious, and others, well, we'll see where we get to. Okay, so you had a quick glance at those, got to the end. I will be coming to those, and we start at the top. And, okay, something completely different from climate change. For those in the UK, I'm not sure whether it's happened in Australia, but I guess David Attenborough gets shown in his TV things get shown here as well around the world. And what's really happened in the last 5 years in the UK, or the last 2 years or so, we've really got concerned about plastic pollution. I know how we're going to do something about it. It's been there all the time, but nevertheless, there's been a paradigm shift that plastics, yes, they're useful, but hey, we shouldn't be throwing them away, we should be much more careful about them. So I want to make the analogy, it's a bit simplistic, but saying that climate change is a bit like a waste problem. Okay, here's the we've seen graphs like that of the carbon dioxide going up. Here's the amount of plastic being produced around the world in million tons per annum. Okay, it's going up and up. And what are we going to do about it? Okay, how do you solve a problem for plastic pollution? You recognize that there is a problem. Well, and that's only relatively recently. The scientists knew it. We've been writing about birds having plastic in their gut for 20 years or so. But now the public, the wider world has recognized that there is a problem. And if it's a waste problem, what do? You reduce the amount that you're producing. So reduce the release to the environment, that's the emissions, and then, right, okay, you clean it up. And it's always a bit messy doing the cleanup, but there's various ways. It's not the most effective way of dealing with it, but there's always going to be some residual stuff out there, and it's far better to get the plastic out of the ocean before it's gone in. It's far better to clean it up at the source to reduce emissions as much as possible, but then you have to do the cleanup. Okay, I think this is going to be pretty obvious now, so you've got the hang of it. There's CO2 going up. What do? You recognize that there's a problem, and then you reduce the release to the environment, and then you clean up as necessary what you can't stop going out there. So nice and simple, and if that can get out to the policy people here beyond this room, then that's the message, that treat pollution and then you clean it up. And that the clean-up is the negative emissions. Okay, let's get on. Now, for Phil Boyd and I go back a long way, 30 years or so, when we were involved in a UK research programme. It was a marine-based ocean, JGOFs and BOFs and things like that. And it was the ocean carbon cycle, but it was climate change. And the reason why we got funding for it 30 years ago was because we wanted to know, or the UK wanted to know what was going in and out of the ocean, the budgets, and what effect on climate change that was going to have. So we were aware of the climate change problem 30 years ago. And that was about the time, and they were planning it for the 2 or 3 years beforehand, the first IPCC report. And in that first report, the quote from there, it hasn't changed very much in the past 30 years. I mean, depending on your definition of business as usual, but those figures have stayed pretty much the same from the first report to the fifth report to all the special reports. So we knew about the problem then. And also in 1990, I gave a talk. It was at the British Association for the Advancement of Science, and I'd heard about some of these things, and I was involved in funding the programme on this carbon change in the ocean. And at the end of the talk, I happened to sort of throw, I think it was the very last slide, about iron fertilisation of the ocean and how it might affect the climate. And that got picked up in the newspapers and it was in the Times Quiz of the Year. So it became public knowledge that the general population, or those that read the Times in the UK, were expected to know at the end of 1990 that global warming is a problem and that iron fertilisation might do something about it. So, but just a little correction. In fact, I was reporting on John Martin. Some of you might recognise that name, but he, an American, and he thought out the concept and led some of the initial experimental studies. Then the UK did some initial experimental studies of adding iron to the ocean and finding out, yes, it was a limiting nutrient. Yes, it did draw down carbon dioxide to some degree. But it was John Martin that we give credit for that. Okay, so that was 1990. 1992, United Nations Framework on Climate Change, and we've heard about what dangerous climate change might mean, but that was when the concept wasn't, it was dangerous anthropogenic interferences with the climate system. But that's what the countries of the world agreed that they were going to avoid in 1992, and they all signed up to UNFCCC. Great, so again, problem solved, not quite. But then rather a long time went by before the Paris Climate Change Convention, the Paris Agreement, defined what it was or came to an agreement what they meant by dangerous. It's still not quite sure, 2 degrees, 1.5, but they realised that there had to be some sort of quantitative value on what dangerous meant. So that's fine, okay, and what we're going to do. And then, just in the last few weeks or so, further IPCC report on the 1.5 degrees warming. But the clock in the middle is the doomsday clock at 2 minutes to midnight. Have we actually made much progress in those 30 years? In lots of science, but has there been any real advancement? Well, we've increased our emissions by 60%. That's pretty good, pretty productive, right? Okay, so and they might have levelled off a little bit, but they're still up there. What atmospheric CO2? We've exceeded the 400 parts per million, 405. That's going up. What else have we done? And the land surface temperature has risen by about half a degree during that 30 years. So what are we going to do for the next 30 years? Another half a degree, maybe less, maybe more? But there's been some arguments, clearly, during that time of whether it was really happening, going backwards and forwards, and in the UK and in the US and in Australia as well. People aren't quite sure, is that really going up? Was there a little blip there? Is that a hiatus? Perhaps global warming's come to an end, just because a few years, a little bit of a wobble. But if you really want to have the true information, and this is to a certain extent my background is in the last time has been in the ocean. If you want to take the temperature of the Earth, take the temperature of the ocean, because that's where 93% of the extra heat that's coming into the system is going. And there's no hiatus, it just goes up and up. And there's some wibbles, but those are the measurement errors, because it's not that easy taking the temperature of the whole Earth's global ocean and to depth as well. But nevertheless, we've now got the instruments that can do that, can take those measurements, and there's no doubt about it that the world is warming up, the heat's going into the system, the zettajoules, and it's thousands of billions of joules. It's not actually in degrees. If it was in degrees centigrade, you might say, that's not very much, 0.01 degrees centigrade, but for the vast volume of the ocean, then that's an awful lot of heat that's gone into the system. Sometimes it goes in one part of the world, sometimes it comes out somewhere else. Okay, those are all the graphs. If you want to talk to politicians, you don't show them graphs because they can't understand graphs, you show them pretty pictures. Okay, what's happening? Ice is melting, we're having droughts, we're having floods. That's extreme weather, but that's the symptoms of climate change, and it costs money, it costs a whole lot of inconvenience, and even in the rich countries of the world, it's an inconvenience that we can do without, and we don't want it to get any worse. And for poor countries of the world, it's a matter of life and death. So we know all that. What are we going to do about it? Okay, so what are we going to do about it? It was agreed by, might have been one or two exceptions, most of the countries of the world in Paris. And at least for the first few months or so, all the talk was on the 2 degrees, and it was called the 2 degrees target, as though that's something we wanted to get to. And it depends on what your comparison is, but for me, the target is 0, and that's what we want. That's the target, and we don't want to get any warmer than what we are now. But if you call it a limit, or limit the increase, and fine and splendid agreement in Article 2, but that got all the headlines, because then governments signed up to that, and they had to think, how are we going to achieve those targets? And they had to come up with their nationally determined contributions of what their climate policies and their climate plans. But it's very difficult for one country, devolving it down to say, okay, what are you going to do? It's much more tangible if they'd actually read Article 4, which, and we've had some discussion on net zero. It's sunk in now, it's a couple of years later. In order to stabilize global temperature, you actually have got to have net zero. If you're in a hole, stop digging. You've got to stop adding greenhouse gases to the system. So you've got to get net zero. And what would have been a sensible target to have, and some countries are doing this now, is to say, well, how rapidly can one country get to net zero, and have a sort of, 19 countries have signed up to it, but in effect all countries have signed up to net zero in the second half of the century, but what's the date in which you're going to get to net zero? And that's and New Zealand and Norway and some other countries and some little ones as well are saying, right, we're going to do net zero by 2040 or 2050 or so. And then that really focuses the mind on how you're going to get there and what you have to do in order to get to net zero. So net zero emissions means, and you could well, it's going to be very difficult actually to do it without any negative emissions. It implies that you're going to have that balance, what goes up, what goes down, you've got to have that balance. Okay, so that's Article 4, and this is we've had one or two slides on this of unfortunately, I think we got the words wrong. That was part of the problem of the lost 30 years, in that we haven't been that good at communicating to the wider world. And here we're talking to ourselves, but for the terms that we've used have had the wrong messages, have had the wrong connotations, have been inexplicable, have been self-contradictory. Even the title of this conference, Negative Emissions, to me, negative emissions, it's on the slide, negative emissions is an oxymoron. And who talks about negative emissions in everyday life? You know, it just doesn't make sense. It does to a modeler because they've got their positive emissions and they've got their below the line, and people who do graphs in maths all the time, they're comfortable with it. They know what negative means. But if you go out in the street, I don't know, perhaps Canberra's different, but in the streets of the UK and you say to 100 people, you know, what's a negative emission? And you know, hey, and the responses that I've had, oh, that sounds bad, you know, negative, yeah, I don't like the sound of that. And so it doesn't, you know, people can't say, you know, so you've got to have language that is intuitive and that means what it says. And unfortunately, I mean, that IPCC and CBD, that they're in their policy world too much, and they don't get out and about enough, and the IPCC doesn't talk to CBD, and CBD doesn't talk to UNFCCC, so they get wrapped around, and the CBD is represented at the Convention on Biological Diversity. Sorry, so I'm into the jargon. The Convention on Biological Diversity is the one UN body that has given a considerable amount of time and discussion, because I've been at most of them, of debating geoengineering from the point of view, starting off, geoengineering is a bad thing and that we shouldn't do it. And that the CBD has passed decisions and resolutions saying that the, paraphrase slightly, but the evils of climate geoengineering, and that they've had moratoriums saying geoengineering should not proceed until there's an international regulatory organisation that can regulate everything. And fair enough that there are some dangers, but then when you ask the CBD or in their decision, what do they mean by climate geoengineering, then they've got any technologies that deliberately reduce solar insolation, increase carbon sequestration from the atmosphere. It's sort of, it's nearly there, but then you look at what sequestration is, and they refer you to the IPCC sequestration, and IPCC sequestration equals uptake, equals removal from the atmosphere. Well, everything, crops remove carbon dioxide from that. There's no temporal indication at all about how long you've got to remove it. It just says sequestration is removal from the atmosphere. Okay, so, and anything that does it deliberately, or, well, there's a whole lot of problems if they don't quite know what they're talking about. Okay, let's have a look. And so I have been involved. This is from a CBD report that I contributed to, which then the CBD, being the representatives of government, they noted the report. They didn't accept it. They didn't say how wonderful it was. They noted it, but it was on the issue of the problems of terminology. And on the left-hand side is what everyone counts as climate mitigation, and that's sort of the good thing. And on the right-hand side is what everyone counts as climate geoengineering, and we don't want to go there, do we? But then in between, there's this greenhouse gas removal. And I call it greenhouse gas removal because that seems to be the most sensible three words to describe what it is, but you can call it negative emissions, you can call it CDR. But anyway, if you, everyone's turning their head, you don't have to read every line there, but there's a whole slew of different techniques and possibilities that we're going to hear about in the next couple of days. So that they're sort of somewhere in the middle, that you can count them as mitigation, you can count them as geoengineering, but just call them greenhouse gas removal. And if we're going to have a sort of typology of what's what, well, this is my contribution. And it's really when you get down to what it is that you're doing, and I think it does help to have some sort of system and structure and realise that what's it all for is either to increase the heat loss from the Earth, or to decrease the energy coming into the Earth, or to move the energy around once it's here. And then you can put all the different techniques and things into those different categories. And then, to me, they make more sense. Okay, so why, I've almost sort of said it already, why do I say greenhouse gas removal rather than carbon dioxide removal? And there is a rationale for carbon dioxide removal, as Pep described, where you can put everything in CO2 equivalents, but I think it makes you much more blinkered and just thinking carbon dioxide, carbon dioxide, carbon dioxide, rather than the climate change problem is not just carbon dioxide, and particularly if we're able to reduce the emissions of fossil fuels, carbon dioxide, we're going to get a higher proportion of these other ones that you can see on the left-hand side. And that's the current mix of the drivers of climate change. If you if you stop the carbon dioxide, you've still got all those others from agriculture and from other industrial processes. So you can cut out carbon dioxide emissions completely, no carbon dioxide, but you've still got those others, you've still got a climate change problem. And so that if you just say carbon dioxide removal is how we're going to do negative emissions, then sort of conceptually you don't think about the others. You don't think, well, perhaps there's some sort of smart bacterium that you can, and there are smart bacteria that use methane as their energy source. If you put them if you cultivate them in some ways, can you extract the methane as it's coming out from some landfill site or from coastal ocean or whatever? Is there some way which you can capture methane and get rid of that? You know, and the UK is funding a small project on that very topic. But then if you call it GGR, it keeps the options open, and it also, all the time, you think, well, if you're having a method that removes carbon dioxide, what are the implications for the other gases? Does it help all of them, or sometimes it actually counteracts and gets things off balance? So, bottom line there was the benefits of carbon dioxide uptake may be much reduced if methane or nitrous oxide release is increased, that it might be by some methods. Okay, and I've been rude about the Royal Society because it was the Royal Society report in the red cover that had climate geoengineering, and the Royal Society report in the red cover that called it solar radiation management, that I don't like at all. But the Royal Society now, recently, and I've got one copy of the big version. I've got some summary copies of published a couple of weeks ago, of the Royal Society and the Royal Academy of Engineering report of how the UK can go carbon neutral by 2050. So it sets out a policy. It's not yet been adopted by government, but it's with the Climate Change Committee at present. It was part co-funded by government, but Claire Perry, the Minister within Energy and Environment, it's now called Bays or whatever business and something or other, is now considering it, and there might be an announcement this week, next week, sometime or never, that the UK will be aiming to go carbon neutral by 2050. But they don't want to say they're going to do it until they can work out, is it feasible, is it possible, what do we need to do on the policy framework. So that's that one. And now our next 5. How am I doing for time? That's about halfway through. That's pretty good. Right, so it'll speed up a little bit for some things. But the original title, I thought, well, have I got to go through all approaches? No, I can't do that. But here are some sort of clustered together in groups of categories. And we've heard about some of them already, but we'll be hearing more about the biological methods for taking carbon dioxide out of the atmosphere, or geochemical ones, generally pretty slow, but we might be able to speed them up, or the actual direct engineering of the physical chemical capture. So those are the main headings. And rough and readily, on the left-hand side, the nearer they are to the bottom, the better the long-term security of storage. So there's lots of different approaches. In the Royal Society report, it recommends some that are sort of relatively well proven and some that are more experimental, but a mix of different approaches in order to get us there. Okay, but in order to decide, for a government or internationally, where you're going to put your investment, do you really spread it out over everything? Do you do more research and development? Do you do some more pilot scale? They're looking, in the UK, they're umming and erring, should we do a sort of pilot scale? And the greenhouse gas removal programme, £10 million. Well, that's nice to have. It's nice for researchers, academics, but the rule was no field work. And if you're really going to do greenhouse gas removal and going to find out is it going to work or not, you've got to spend a lot more than £10 million. You're into the thousands of pounds, billions of pounds, in order to make sure to take it through the different scales. And one of the reasons why we got £10 million for greenhouse gas removal. Well, at the same time, the UK cancelled its carbon capture and storage programme that it was going to spend several billion pounds on, and it said, oh, we're not going to do that. No, it's too expensive. So that was actually at the time of the Paris Climate Change Convention in December 2015. It didn't get much publicity at the time, but the UK dropped out. Now we might buy ourselves back into carbon capture and storage, but clearly some of these approaches do require that in order to put the carbon away for a long time. Okay, issues here. I'm sure you've had a quick glance at that. Scalability, all the associated impacts on environment, human environment and natural environment, the security of storage. this sequestration, how long is it going to be kept out of the system for? And the next one down, can you quantify it? Can you measure it? Not just saying, oh, it's probably happening, but can you keep track of it? And for a whole lot of UN bodies, and they're having all sorts of problems with the forestry and the RED Plus, or whatever it's called, for the quantifying forest cover and the amount of carbon. Is it natural? Is it managed? But you've got to have rules about these things if there's going to be international carbon trading and crediting, and to know is it that your carbon that you're buying somewhere in the world is secure for 10 years, 100 years, 1,000 years, or whatever. And then all the socio-economic consequences, and all this big word governance that can mean as much as you want. So in one sense, everything is governance, because everything determines the feasibility of whether it's going to happen or not. Is it just a concept, or is it actually someone going to do it? And if you're going to do something, then governance is necessarily involved, because then it requires players and actors and all the and money and all those other issues. Okay, so I might come down to one or two of those at the end, but let's carry on. And then for one of the exercises, and the UK programme hasn't done this, but I was involved in an international study that published earlier this month. This figure doesn't actually appear in the international study, but it was a comparison of different approaches, and this is just a subset of some of the greenhouse gas removal, some of the marine ones, to try and get them all on an equal footing, to say, well, can we, and although it's in shades of red or green, can we have some sort of basis for comparing this one against that one for its effectiveness or its ineffectiveness? And what I've done is sort of simplified the results of that analysis by putting the good things about a particular, sorry if anyone's colourblind, but it's green on the left-hand side and red on the right. Green is good news and red's bad news. And for the comparator, the one at the top line is the marine renewable energy, which we know how to do, and we're just not doing it at the scale required, and all the others are the negative emissions compared to the benefits in terms of carbon dioxide saved of different approaches, and scoring highly or not so highly on their good features. But if they've got a big red blob, then there's something of concern. Either it's not ready, or there's going to be potential problems in the future, and it's going to require some sort out. And it's almost, well, in order to one can do these relative assessments, then it's for someone else, then it is the politician's job or society's job to have the value judgments. What do we care about the most? How are we going to weight these different factors? Are some more important than others? And sorry that the type's a bit small there, that might make it a little bit better for those at the back, but you can have just a glance at them, and again, the scales of some things that work out well on one basis, but not so well on another. Okay, back to that one, and there's one I've circled there, coastal blue carbon option, and I haven't read all of the US report that was published last week, but I did read the BBC online summary of it that said blue carbon is the answer. Well, that was number one of their recommendations, sort of nice and easy, nice and socially acceptable, but will blue carbon be the problem of calling them solutions is that, to me, solution means that you've solved a problem. But it's sort of, you might solve a little bit of the problem. Let's have a look at blue carbon in a little bit more detail. And part of the excitement about blue carbon was the graphs that you see there. Elizabeth and Cloud published them a few years ago, and showing that blue carbon, this is coastal vegetation systems, they have much higher rates of carbon uptake than the forests on the left-hand side. And so that the idea was, well, these are real sort of hotspots for carbon going into the system. But there are some complications and some issues on those that are, and that under the overall heading, my premise, removal must be reliably quantified and secure, otherwise it doesn't count. You know, that you've got to, there is a phrase about if you can't measure it, you can't manage it, or something like that, but that's along those lines. Okay, so different coastal wetlands, is that our solution or not? And then the issues that are raised is sort of, if you question natural solutions, it's almost as though you're anti-nature, and that you're sort of, well, and nature solutions are what people want. You know, that if you ask people how are you going to solve them, everyone likes planting trees and doing nice green things, but will they really work? Will they really deliver? Okay, and the one aspect you wouldn't be able to read it on the slide, or perhaps I didn't even put it on the slide, that those are rates of carbon. It's a log scale, so that there's 10 times as much, but those are rates per unit area per square metre, and that there's not quite so much of that coastal vegetation as there is of the forest. So that if you've got to do it, if you make the true comparison, you've got to compare the total area. But if you're saying, well, we've got so much money and we want to improve one square patch of land in some management way, well, perhaps this is the answer, and put your money into your 1 square kilometre of coastal and get some other benefits as well. Certainly not saying don't look after your coastal vegetation, because it's really important for lots of other reasons. Okay, but on the left-hand side, the green is the forest uptake. Well, that's really, for a mature forest, there's pretty damn all carbon uptake, apart from what's stimulated by the rising carbon dioxide in the atmosphere. It's not unless you plant a forest or have some peat bog or something where it's accumulating. On the left-hand side, those terrestrial systems are not carbon accumulating systems. They just sort of sit, and it's the way of nature. It sits there, it's carbon in, it's carbon out. But we'll be coming back to in a moment. Okay, and the question that I did allude to of having greenhouse gas, what are the other gases going in and out of the system? And we have some data for salt marshes, and we have some for mangroves as well. The reason why they're storing carbon in their sediment in this salty water, and the leaves drop off and the roots drop in, and they go into mud, and it's anaerobic. There's no oxygen there for the breakdown of the carbon dioxide, but because there's no oxygen there, there's bacteria there that give off methane. Because they don't turn it into carbon dioxide, they turn it into methane instead, and methane is much more potent as the greenhouse gas, so that about 25% of the benefits of having carbon storage is offset by the methane coming out. But it does vary, and there's lots of issues about that. Okay, and there's the error bars there are the range of reported values, and that there are different, and not surprisingly, and although these ecosystems exist around the world, there's different values for different systems. Why is the variability? What causes that? That's a pretty important question to ask. But more important, and this relates to soil on land as well, and the forests on land, what about the future climate conditions? Even if we're super successful, we keep it to only another half a degree or only another degree warmer, what will the soils in these coastal systems, or the soils on land or the forests, will you still have the same vegetation there? Will that habitat be the same? And for the coastal system, then you've got the rising sea level as well. So even if you constrain the temperature increase, the conditions will be different, and therefore you've got to have the projections, you've got to factor that in as well. And then there's a question there that I think this might be discussed in tomorrow's morning session. These are estimates. Some of them are sort of measurements, but they're based on the amount of carbon sitting in those habitats. But for seagrasses, then there was a paper a couple of years ago. It's highly contested and contentious, but people said, well, actually, all this carbon there, did it accumulate over 10 years, 100 years, or 1,000 years? It really makes a difference of the rate at which it's going in. And that for a number of reasons, that there's a really interested in this topic, have a quick glance down, that for seagrasses, there are a whole lot of uncertainties of whether they are quite as effective as they looked as though they were from the previous estimates, and that these particular authors estimated that they might have been overestimated by either tenfold, just an order of magnitude, or 3,000 times for scaling up, and that's quite a big range. So we ought to be aware of those issues, and I hope to be able to discuss those in greater detail. Okay, so I haven't been directly looking at blue carbon, and the greenhouse gas removal programme hasn't been looking and hasn't got any sort of new data to present, but I've been involved in a programme called Shelf Sea Biogeochemistry that's done carbon budgets for UK shelf seas and coastal zones, and just recently published a sort of summary diagram of what we think, and for the Northwest European shelf seas, probably the best studied in the world. There's still all sorts of errors and uncertainties about how much carbon is going in and out of the system, so most of this is sort of natural exchanges. But if you want to say, well, what about the blue carbon in the salt marsh? Okay, well, we've lost quite a lot of those habitats, but for the UK or for Europe, then the amount going into salt marshes and coastal habitats is pretty teensy-weensy compared with the large amounts, the large arrows going in and out. And some of them we don't even know for the sea floor, whether there's actually carbon accumulation on the sea floor or carbon being released. and it probably depends on where you are and all sorts of, and the trawling intensity and all sorts of other conditions. So there's all sorts of uncertainties there about managing carbon in a natural environment. And now for deference to Phil Boyd, wherever he's still there, credit to you for this image. But saying, again, natural sinks are actually cycles. It's relatively easy to measure the carbon going into a system and to call that sequestration and say, hey, you know, how many thousands, tons, gigatons or whatever can go in. But then most of the time for a natural system, what goes in comes out somewhere else, and you might get these other greenhouse gases as well. So some of it might be taken out on a long-term basis. Some of it might go into mid-ocean, but if you've got to keep track of that, and if you want carbon credits for it, and someone wanting to say how much of that is still there in 50 years' time or has come out somewhere else, then that's not an easy question to answer. Okay, I think I'm coming to an end. I hope so, because I'm getting a bit, nearly. Pep introduced the idea of overshoot and sort of saying, well, I'd rephrase it, sort of polluting now and cleaning up later. And in those integrated assessment models, that makes sense because of the way the economics, the premises of the economic people is that things are always going to be future discounting. Things get cheaper in future. Things get easier in future. Put it into the future. The future can solve it. And so that for the costs, then you can have a high cost in the future. But for carbon, it switches around. That if you leave your problem too late, and all the preoccupation with IPCC, UNFCCC as well, end of the century to 2 degrees centigrade. But if you're doing an overshoot before you get there, if you've lost all your corals, if your ice cap's melted, if you've gone over thresholds, then however much carbon dioxide some of these things aren't easily reversible. So you've got to then, it brings it back to the here and now, saying it's much more effective not to release the 1 ton of carbon or the 1 gigaton of carbon now than to try and get it back again in uncertain ways in the future. So that's sort of focusing on the here and now. That if your forest has gone and your habitat's lost, then and if your species go extinct, you can't bring them back. So that's the argument for here and now. And it's a bit of a cliche, but anyway, that for life cycle analysis for BECCS, and this was a previous US study that said, okay, that the bioenergy with carbon capture and storage, yes, we've got this ton of carbon dioxide going in, but then you've got to work out all the steps along the way, how much energy goes into that system in order to capture that ton or 100 tons of carbon dioxide to put it somewhere else. And okay, you can use renewable energy for it, but the efficiency of the whole process, not just for BECCS, but any other process, and the wider consequences within, if it's small scale, fine, who's worried about it? But as soon as you get into the scaling issues of some of the things that have been built into the models without any sort of red lights flashing and saying, you can't do this, you can't do this. And that, part of that, in IPCC models, they don't have national boundaries. It's just the globe, and you just do land use things. But you've got to do it country by country. Which country is going to do it? And for a CBD meeting, when I gave a presentation on BECCS and climate changing, the Brazilian delegate said, "Oh, why do you call bioenergy geoengineering?" And I said, "Well, bioenergy is only geoengineering when it's linked with carbon capture and storage, because only then it has net removal." And the Brazilian delegate said, "That's all right, we're not going to do that. The carbon capture and storage, no, that's geoengineering. We really don't want to go there." But so all these consequences, all these effects. Okay, that's it. Thank you very much. Thank you. Since I've finished early, I'll take a question if anyone has got one. But
I'll let Phil actually catch his breath for a second. There's almost a rush of wind up here on the podium. Any questions or comments for Phil?
So I noticed that you talked about plants in the water. I was wondering what you thought about algae systems on land that we can grow and then potentially feed them to the krill. So it could be possible, but I wanted to know what your thoughts on that was.
Great ideas. I'm certainly not against innovative ideas and algae or macroalgae, microalgae on land. There's all sorts of processes that you've got to go to in order to get the climate benefit, and you've got to do it on a large enough scale, they can make a contribution. I think that the sort of warning is don't rely on that, but have that as part of a package of doing other things and explore the co-benefits. It might sound as though I was a bit against sort of coastal vegetation and blue carbon, but blue carbon and coastal vegetation, I'll get all these things. If they've got other benefits, great, go for it. And then if you can get something else included, so much the better.
Yeah, Phil, thanks. It was a very inspired talk, very quick as well. I'm a bit worried when I hear the words overshoot and tipping points and thresholds mentioned in one breath, and the critical one, the slow feedback's not mentioned at all this morning or even now. Even if we don't go into an overshoot, we're going to keep on warming and we're going to keep on getting all sorts of releases happening. So what's your view on the political driver on 2100?
The driver for 2100 is once an international body has made a decision, then it's very difficult for it to change that, and that's the way that things have been structured now. And within IPCC reports, there are chapters on long terms, and politicians sort of are aware of them, but they generally prefer the shorter term of the implications for within our lifetime rather than the end of the century. But I fully agree, and it's a different presentation on the issues of the imbalances, the asymmetry, the long-term effects, and are you on the programme or not? Great. And if not, then it's for other people to highlight those as issues. But I think that the overshoot, and even within the 1.5 degree report, I couldn't find, or at least not in the summary for policymakers, it might be there somewhere, but in the previous AR5, the temperature overshoot for different, and there's lots and lots of graphs showing the emissions coming down, but there aren't very many graphs showing what's the temperature doing in response to that. How much over 1.5 do we go before magic works and we get it down again? And I think that has been missing, and I'm now I'm a sort of doubly guilty party in that hey, I travel around the world and lots of carbon dioxide emissions, but I'm also now, for the first time, part of an IPCC group. But it is very difficult when they say, well, that wasn't in our chapter structure. You can't talk about that. No, that wasn't approved, and things get missed out or moved around, and so there are constraints. And then they say, oh, the governments have got to approve that. Don't put in anything that seems at all policy prescriptive, because then it'll just get crossed out when it gets to the policy session. So you've got to play the game to a certain extent, but none of these organisations are perfect. They're the best we've got, and we've got to support them, but we do have to have whatever the transformation step change is in the next 5 years, so that we've got to do as much in the next 5 years as previously in the 30 years.
We'll take one last question. I think this gentleman here.
Yeah, thanks for that, Phil. John Ridley from Ocean Nourishment. I think that's the most refreshing presentation I've seen in 15 years on this topic, and I really hope it's recorded.
Well, I hope it isn't, but...
Fabulous presentation. But you can see how this area has been a political football for that whole period, and I think scientists have been playing in this football match as well, and NGOs have been playing in the game, and sitting in the stands are the fossil fuel companies watching and probably having a beer and a good laugh at what's been going on, yeah? But I think with the science, well, I noticed Future of Australia are one of the sponsors here. Can you comment on the structure, restructuring potentially of science, and how more effective it could be if we change the structure of our universities and our science?
I think I'll pass on that. I mean, it's a great question, but I keep thinking, oh, there is some sort of ideal world out there somewhere, and that if only I worked for this organisation, then everything would be fine. And so, although I've stayed with NERC, but I've worked in different laboratories and different places around the world, and that you always sort of come up against some problems. Nothing's perfect in this world, but things do change, things do happen, and that you now know that, and sometimes it's bad news that you can't rule anything out, but sometimes it's good news that things happen, and you say, wow, we have done it. We have succeeded. We have got there, even though it might have taken quite a lot of time and effort and things, but or a whole lot of effort by other people. So it is changes. We have to believe that it is possible, even though one sort of goes into the pessimism. But yes, it's going to get worse, but we can stop it getting a hell of a lot worse. We can have some actions, and if we inspire other people as well, then that's all for the good.
Well, thank you for those questions, and let's thank Phil for a very stimulating presentation.